Okay, so I'm here to give a quick overview of the AI Data Technician project, which is an agent system that works with scientists to inspect, analyze, classify high-dimensional time series data. So the motivation of this project is that in many scientific domains, such as neuroscience or astrology, which they work with a lot of high-dimensional, high sample rate time series data from the raw sensors, um, they currently lack automatic tool set to help them, for example, inspect the data, reject noisy data, or do more precise classification. And this is because no LLM currently can directly work with these high dimensional time series data. And a lot of these data require very nuanced expert domain knowledge that is difficult to transfer. So therefore, we developed this system to have any interactive human AI collaboration so that the expert knowledge can be slowly installed into the agent through interaction. And the persistent memory plays a very key part in this process because it's what truly enables learning to happen. So, going more into the details. So this agent has a main orchestrator agent that is powered by Claude Sonnet and uses tool calling to um, as a very flexible way of conducting multiple different kind of workflows. In addition, it will be also have a task agent. So essentially, it's kind of like an agent with a defined set of iterations with a smaller set of tools that the orchestrator agent can dispatch to handle more detailed workflow. This is done so that it will not, if the task is too complicated, it will not overwhelm the context window of the orchestrator agent. There will also be a think agent, which essentially just a call to the LLM with extended thinking to work on tasks such as like memory extraction, compaction, and session reflection. So these are all things that's related to memory, which I'll go into more detail later. First, I've defined it a pretty broad set of tools that the orchestrator agent can use. Um, and this is designed so that they have maximum capability to work with data set of all sort and conduct a variety of coding analysis tasks. So notably, the vision tool is a call to Gemini vision language model. It's the most capable vision language model that we have so that the model can directly seize the plot that the human scientist research is seeing and absorb the feedback more directly. We also have the plot tool to plot the signals in an interactive or static way using Plotly and Matplotlib. The recall and remember tool are essential for the memory system. So it's what the agent used to retrieve and store information that it sees important. And the task is the sub-agent. They're also available of Ask and To-Do tool for the agent to use to interact with the user for clarifying certain questions and to-dos for more complex task. So I'll be going over the demo of the web interface in a little bit. So here I just wanted to talk more about the memory system. So as I said, a memory system is very important for the AI data technician because the main goal of it is to interact with the scientists and absorb the domain expertise and be able to apply to accumulate these domain expertise as interaction with scientists go on and be able to apply them in future analysis. So essentially learning what the scientist is teaching it. So a couple things that could get remembered are, for example, processing parameters. If there is a certain way of plotting that the user likes, then it can get remembered. Signal patterns, these which often involve many years of training to develop those intuitions from scientists. We're able to have the agent to also remember what the patterns look like, what are some statistical features and some example patterns that I can use in the future. We can also use memory to store procedures, so a way of conducting certain type of analysis or some labeling protocols, as well as more domain knowledge that does not readily exist online and is more niche to the scientists, a specific domain or the scientists themselves defines. So in general, there is a three-layer architecture for memory. Layer one is sessions, like the working memory of the agent. So essentially, that's just the conversation turns between the agent and the user that gets attached to the JSON file. Um, and this will be attached to the agent at every turn so that it remembers immediately what it had done before. But as context grew, these will also get compacted. However, every session turn also gets remembered in the EverMemOS storage system. More long term, it will not be impacted by the compact, so it's a really good way of keeping track of the record. So there's also a project-wise memory that in the file storage gets stored as a project memory.md that attached to the agent at every turn. But this one is also limited to a certain context. Therefore, it is very good that for the EverMem storage system, we can um, like put these chat turns into episodic memories as well as any kind of reflection or summary that the agent does after a couple of turns. It will also get stored in the EverMemO storage system. And in addition to that, there's also a global layer memory architecture that is available across projects. And likewise, in the storage, there is a global memory.md limited. For the EverMem storage system, there is a unique group ID called the global group ID that gets stored reusable procedures, user preferences, and cross-project insights. So the user has the option to use the file storage or the EverMem OS storage or hybrid, which writes to both. And the EverMem OS system really comes into shine at specifically the project and the global level, because the hope is that the scientists, as they interact with with the agent and install its domain expertise, these insights will also be able to shared across projects, across scientists, even across labs to develop um, industry like standard protocols or patterns or stuff like that. So yeah, and so the life cycle of the memory is whenever user teaches something in the chat panel, this will trigger the orchestrator to call the remember function that will store that piece of information. And after every 5 messages, the think agent will also review the history and just consolidate more important facts if it sees those information exist. Um, and after every session ends, um, they will also be able to do a little bit of reflection to write to the global level. And for every session, there is project memory, global memory will get loaded into the system prompt automatically. But the agent is also able to use a recall tool whenever it sees a domain specific knowledge or some kind of um, user request that needs to retrieve previous understanding. So, yeah, so the Evermem OS system is very important for those purposes. Um, and right now, I'm going to give you a quick demo of the system using a Mayo data set. This is a neuroscience data set that consists of intracranial EEG signals. Um, and yeah, this is basically just the architecture of the agent in a diagram with a orchestrator agent in the main spot, and a couple of tools and the sub agents that I can call, as well as the memory backend attached to it. Okay, let's get to the demo. Okay, so let's first create a new project. We can call it a demo. And the user has option to create sessions, but now we're just staying in the new session. So first we can ask, hello, tell me what you can do. And so basically the status bar here shows the agent is thinking, the activity log shows kind of the internal process. So here the agent is providing an update. Um, and it's telling us that it can do data exploration, visualization, statistical analysis, classification, rule building, file management, stuff like that. So now let's give it a data set. I want to begin a project with this data set. So here I can pass it to a direction on my file, but in the future, in the deployable URL, can also be able to upload data set. But this is just in case if the data is very sensitive, it has to exist locally. Um, so here, you can see from the activity log here that the agent, the orchestrator agent, launches a bunch of tool call to go through the data set in more detail. So it's taking some time to read files, based on bash command to look into the details and provide some overview. So this is very good because the scientist doesn't have to pre-configure their data into any type of set format. Like essentially the agent can deal with all sorts of file feedback, file format. So correctly, it says there's metadata, a paper also included, acquires some background as well as the raw signals. It also computes the size of the raw signals and some of the metadata data detail. Um, so here we can also ask some details about the paper since the agent already read it. So we can ask stuff like, can you explain to me what is SO? Um, so there is a very capable language model. So they're also able to answer a lot of like questions. But if we enable it with like web searching tools, then you can also do web searches. Oh, I see. So the agent here recognizes the SOC is a domain relevant term. So that it actually did try to recall from its memory system if there is previous instances of um, like such relevant knowledge. And it seems like from the global memory, because this is a new project, obviously there's no memory, but from the global memory, perhaps the scientists could have worked with it. In this example, it might be reminiscent a memory that was stored from a previous test trial working with this data. But here, so it answers some questions about giving a explanation of what exactly is this domain relevant term. So we can also see from the cloud um, system here that we have a demo project and all the conversation is getting loaded to this cloud memory system as we speak. Okay, so now we can ask it to do some visualization. Can you give me the raw time series plot, spectrogram and PSD of a random signal in the right hippocampus? So you can actually write in a natural language what kind of data you wanted to see. Um, and the agent here launches more tool calling to make sure that make sure that the signal contained is from the right hippocampus. Um, and then just executing some plot execution tools. So the reason why I designed the system to have a bunch of tool is um, like to really trust the reasoning capability of the orchestrator agent and allow with a lot of flexibility. So they can assemble these tools in a chain to deal with very complicated workflows. Obviously, we can also define specific workflows, but giving a tool allow it for maximum flexibility. So here we can see some plot being generated. Um, we have correctly the time series, the spectrogram, as well as the PSD. These are all very common plotting tools that we use in science. However, we can also give more specifications. So, for example, here, I think I wanted to change some parameter of the spectrogram, which the scientists might always have some customs parameters. So can you alter the parameters of the spectrogram to show a more clear vertical power band brightness? So the agent is thinking. So actually, it launches a vision tool to look visually inspect the plot. So here I gave the model a vision tool to query a Gemini model, which is the best vision language model right now to actually physically see the signal. And it is designed this way because um, this is how human kind of reason about time series and can give more feedback directly using this method as well. So um, therefore, I think that the vision having the vision capability is very important. So here you can see it says it saw the original plot and it proposed a new plotting parameter that looks very different from the previous one. Um, okay, so it took some time to run the system, and now it's fully launching a script to try to align the peaks. So wow, it's able to do some pretty cool analyses. So we can see that the consensus is at 1.68 second. Okay, so it's saw some peak here and doing some statistical analysis and trying to align them. Um, yeah, a scientist can judge whether it's done correctly. I can say, I want you to remember to plot the spectrogram using the new parameters. Okay, so now we can see that all of these memory are also recorded, and the agent launches a remember tool to remember the spectrum parameter. Now we've shown the agent's capability to see plots and run analysis. Okay, so now we have finished our previous session and arrived at the new session. We can try to see if it remembers stuff. So, can you tell me what's the ideal spectrogram configuration parameter? And in the activity log, so it's trying to recall which pull-ups with these queries, and then they will pull up some memory, and the thinking agent is used to go through the memory to give you the final answer from the previous approved visual inspection. So yeah, so this is a successful retrieval of a previously stored information. And if we actually go into the cloud, we can see that, after 5 turns of conversation with the agent, the system automatically wrote some summaries about the project, also writing about the data set, recording some domain and analyses, as well as these visualization that we have done. Um, and here we're able to also see that these parameters also get stored. So this is a very good use of the EverMemOS system.